Hello everyone. I'm still sick, so pardon me if I'm coughing stuff. I don't know. This is the part of the stream where I complain about my body. I feel like 70% better. Hey, look, it's me. Yeah, it's rough. So many like today was amazing how many mods came out that just announced and stuff. We got the Make Megahertz. Hey Christopher, how you doing? Yeah, the Project Stellar was announced, as well as the V2 Xbox H2 Plus stuff. I'll do a better explanation for this week's retro modding news, so don't worry about that. But also Voltar did a sneak peek of his this 2-chip SNES RGB bypass, whatever they're gonna call it. I don't know what he's gonna call it, but let's see what else. Oh yeah, so Energy open sourced his or he released the files for the WonderSwan consolizer, so that's fun. All right, there's a lot to do today. I'm not gonna just chit chat about new mods, but we got a lot of work to do. I don't think I'm gonna do really like a talk about what BlueRetro is. I'm just gonna say that it's an open source project that lets you use Bluetooth controllers with a wide variety of retro consoles. So I'll kind of leave it at that, and then I'll go over to the bench and we'll talk about what we're gonna do tonight. Hopefully everyone can hear me. Oh, never mind, my mic is all wonky over here. Sorry if there's any noise. I'm gonna move my mic. Excuse any noise. Okay, hopefully you can hear me better. Let me know if it's loud or annoying. All right, let me untangle myself. Got my chat up so I can see spam messages. Okay, what you're seeing here is my excuse to learn how to use KiCad or KiCad to lay out a circuit board. All right, so BlueRetro, the project, Darth Cloud is the creator of BlueRetro, and there are a couple of, it's open source for one, which means that on his GitHub, there are a lot of files that kind of Darth Cloud has uploaded that help you to either make your own, or some other people have also open sourced their versions of it, and some people actually sell pre-made ones. However, BlueRetro itself is not like a specific implementation, right? Meaning you can feel free to create one however you want it to look, and he has schematics on the GitHub to kind of help you with that. So maybe if people are interested, someday I can go over what I did to create this board. But for this stream, I'm gonna actually, it's got some cool silkscreen in the back. It says NES or /SNES, because this should be able to work with both. This is just a prototype, by the way, so I have yet to populate one of these boards to see if it works. But and this is also wrong. ESP32 Room 32E is not the name of the ESP32 dev board. That's just the name of the ESP module, ESP32 module here. So I mislabeled this. So this is a sort of a screw up. But this, and let's go back to this first. So it says implementation by me, meaning I did not design the circuit here. It was developed by Darth Cloud. So Darth Cloud developed the circuit. I just laid it out. So maybe I should, no, I'll do that in another stream. So what does that mean? He has schematics. So like literally he has part numbers that you can use and how they connect to each other. So each of these pads goes to different pins here, which goes to different pins on this dev board, which I'll talk about in a second. And he lays that out for you on his GitHub, so you don't have to worry about that. You just have to worry about basically putting them onto a layout. Yeah, I think it scares Trevor. I think it scares a lot of people. Hey, Postman. Sorry, I'm like 50% here tonight. So, so if I'm like I forget your name, then I'm sorry. So yeah, it seems scary, and it kind of is. The scary part about KiCad is having to create your own footprints and stuff. Maybe I should just do a whole stream on that. Like, I think people might be really interested in that. Hey, Viper, how you doing? So anyways, I'm going to spare that because there's a lot to do with just this prototype in general. So I have a lot of things to do. So this board, what I developed, this is the ESP32 dev board. An ESP32 basically is like an all-in-one. It's just this top part here. What you see underneath this, this is a metal shield because this actually has a built-in antenna here, right? So for like, it's basically this part of the dev board is really the what really is the ESP32. And if you unsolder this, it'd be like a little piece. That's the ESP32. All the brains, all the interface with the antenna, Wi-Fi and Bluetooth, like that's all done just in this little part. So the rest of this dev board, the reason they call it a dev board is because there's additional features on the dev board that allow you to use this ESP32 easily when you're developing a new project. Hopefully everybody can hear me. I'm not too loud or too soft. The main features that this dev board give you that are not built in are these two buttons here. There's a status LED somewhere on here. There's a voltage regulator. This is they also call it an LDO. But what that means is this ESP32 itself, just the ESP32 module and the MCU, operates at just 3.3 volts and not 5 volts. So if you tried, actually I've heard that ESP32 module can run at 5 volts, but anyways, we won't go into that now. But it is supposed to have 3 volts. So the voltage regulator takes in 5. You can give it 5 volts, one of these pins, or not that pin, a different pin, and it spits out 3 volts. But that is kind of built into this board, as well as all the things needed to connect this via USB. So there's a USB port here, and there's this chip here, this IC here, is some kind of like a ESP32 serial device that like allows you to use this USB port to flash the firmware and stuff. So yes, as you can speculate, the ESP32 module itself doesn't really give you a way to flash itself unless you had some kind of a jig to connect it to these small pins up here. All right. Hey, pancakey mate. How you doing? All right. So when you go to the BlueRetro GitHub, there are schematics broken out by console, right? And it just so happens that the schematic for the Super Nintendo version is very similar to the NES version, with like basically it's just connect a pin to a different like ground for the Super Nintendo or something, and like 3 volts for the NES. So I put this little jumper. So this prototype would be compatible with both the Super Nintendo and the NES. So what is this then? So this is what I'm calling a shield, because in like if you're familiar with like the Game Boy Advance or the GBA HD, which is the Game Boy Advance consolizer, it uses like an FPGA dev board that sits on top of another custom PCB kind of like this, and ManCloud calls it a shield. So I stole that, and like I'm using this as a shield. So this is when I made my own shield, and it really is just to implement Darth Cloud's schematic on a physical PCB. That's really all I did, which was a lot of work. Don't get me wrong, it's not no work, because if you look, you can kind of see in a certain light the traces and stuff. I did all that routing by hand. I had to figure that out. So the end goal is to populate all the pieces here tonight, and I'm hoping to do this tonight. There are these 3 chips, 1, 2, 3 here, and each one has its own power bypass, or not, like power filter cap. That's what the C's here, and if you noticed, the U1 C3 and U3 C1 are backwards. That's just a dumb mistake. So that's what these are. These pieces, and without like diving deep into the schematic, these essentially are level shifters. And what does that mean? The Super Nintendo, these pieces here, so J1 and J2, my ultimate goal is to use JST PH connectors and 90-degree ones, so that I could make this a nice and then I would have to make like a nice enclosure for it. But I could make like a nice like finished product that you could. The other part I've got is these Super Nintendo controller extensions, right? So I'm gonna be hacking one of these up tonight, if we get that far. I think we're gonna. But this is what's actually gonna plug into the console. But like I would cut it off, and then in the future I would get a JST crimper and the other parts. Right? So this is the male end. Is it the male end? Is this male when it has the parts sticking out? So I get the female ends, and I would crimp the actual Super Nintendo controller connector into a little like adapter that would just stick in here, and that way and there's two, right? So player 1 and player 2. And what's interesting is when you implement his Darth Cloud's schematic, it actually includes the multi-tap functionality. I think that's what it's called with the Super Nintendo. So I'm not actually sure what that means, but maybe some games support up to 4 controllers or something. I'm not really sure. But that is supported with this board, Shield. That shrouded JST. Yeah, it's kind of interesting, right? And it's like, JST is cool because it's notched, so you can't put it in backwards unless you like mangle it. So it's nice. So like if you do up these Super Nintendo controller connector or extensions, and the JST, like you don't really have to, like when you connect and disconnect them, you don't really screw up the orientation, which is cool. So anyways, I don't know. I'm not going to do that tonight. I would directly solder the controller connector onto there. So we'll see if we get that far. All right, I've been talking a lot. Let's do some soldering. I need to turn my soldering iron on. I have all the parts. I ordered them from DigiKey. First thing I want to do before I forget is solder this. I'm gonna do the Super Nintendo. Attempt a Super Nintendo. I don't know if this is gonna work yet. I'm pretty sure it will work. I implemented the schematic. However, I did not flash the firmware on this yet, so I do not know if I'm gonna have time for soldering everything and then flashing. I don't know, so we'll see. All right, got my soldering iron coming on here. 650 degrees Fahrenheit. The pins are set up higher in that connector. What do you mean? Like it's are you trying to tell me that this is a bad connector or a good connector? I don't know. I just like JST. I don't know, for some reason. Or because JST, when you say JST is a family of connectors. JST PH is a specific type of connector. It's the size and the pitch of the pins. So JST PH is what this is, because there's bigger and smaller ones as well. All right, iron's on. I'm gonna start by bridging SNES, and if I was gonna make this, if I'm gonna keep going, so this product is for my own personal use. However, I do realize that people might be interested in something like this. If you look at, well, that'd be difficult to do. If you bought one of the other BlueRetro things, I'm just gonna solder the SNES side of this jumper while I'm talking. The pins in the connector are offset higher, so you can't put the. Oh, that's right. Yeah, so that's an additional way to not screw it up. I see what you're saying. What was I talking about? Oh, yeah. So like if you look at other BlueRetro adapters, if you bought one, like there's the N64 one that 8-Bit Mods, is it 8-Bit Mods that sells it now? Or like there was the Will's Console Mod sold the PlayStation 1 one. It's very compact, like all the stuff is very tiny, right? The stuff is, so like I wanted this to be sort of like an intermediate board, right? So if you're already familiar with soldering and you really wanted to get more familiar with surface mount soldering, like maybe you have a bunch of through-hole soldering experience, like that's easy for you, but you want to get more experience with surface mount stuff. I think this is an interesting, there's not too many pieces. There's only 1, 2, 3, 4, 5, 6, and then the LEDs up here, LED in the resistor. So 7, 8. I don't know, not that many components. So it wouldn't take that long to solder up, and it's kind of just a, I don't know, training thing, I guess. I don't know. All right, maybe I'll start with the LED and the resistor and the capacitors, because those are tiny. So hopefully my address is not any of this stuff. Non-inventory label. This is a blue LED. It comes in this giant. They come in these silver packages. I need a thing. All right. They come in these because it's like anti-moisture, so it's not just anti-static, it's also like moisture resistant. I don't know, for some reason LEDs need that. Do not know why. If anyone knows why, let me know. Let's see what goodies we got in here. Oh, and for those who understand, oh, this is like the moisture thing. If this is pink, then it's been absorbed. Moisture has gotten in here. If anybody knows, these are all 0806 size, which is pretty big, relatively big for surface mount. So that was the other goal, was to not make them like, what is it, 0402 or smaller. Yeah, well, Ben, I'm probably gonna mess that up, because the thing about LEDs is it's like not negative and positive terminology. It's like cathode and anode, and I was not a great student of electrical engineering, and I didn't I would just, I don't know, I just would want them labeled positive or negative, but it's not that easy. So I always end up soldering them on wrong and then having to resolder them after. Come out, dingus. So let's actually get one of these out of here. Come on. So the LED might be smaller. Oh, I'm gonna lose this. See, this is why I bought a ton of these, because if I lose these, then I don't have to go find them. So it's really small, and I'm sorry that my 0803. Okay, yeah, that's right. I'm sorry that my camera doesn't zoom in further, but I'm gonna try to get you a glimpse. Oh my God, what are these? Is it the wrong things? I guess they're not, but they're just hard to see. Oh my God. Okay, so. Yeah, this is definitely not going to show up on the camera, but I'm going to try to orient it and describe it anyways. There's a little green dot on the left side, bottom left corner of this. This is like impossible. This is like half the size of a grain of rice, so maybe I messed up with this, but that indicates something, cathode or anode, and they never tell you on the package. I'm sure it tells you in the data sheet, but then I soldered it wrong anyways, so. Oh, and the other thing is I don't even know. Oh, I didn't mark it on my board. Which side is which? Oh, God. Yeah. Well, maybe I better skip that, because I might have to go back and look at my might have to go look at my schematic to know what is what. Actually, I should be able to tell, because it's connected to the resistor. So that would be like the voltage side, and the other side is just the ground side. 50-50 shot. Yeah, all right, I'll just send it. All right, so here's my method for doing any kind of surface mount, either like a resistor, a capacitor, or an LED. Choose whatever hand is your dominant hand, so whatever one you solder with, and that is the pad. So like, for example, I'm doing D1 in the middle, in the top middle here. Solder that pad first on the side of your dominant hand, right? So I got D1, okay, like that. So put some solder already on it. Then I'll add some liquid flux on top of that. Hopefully it doesn't dry up. Then do Russian roulette to decide which side is your cat. So what does that mean though, Joshua? Like, does that go to the ground side or the voltage side? Hey, Veridor, how you doing? So let's assume that this is oriented correctly, and I already know it's not. The resistors and the capacitors don't have polarity, so that they're easier. But all right, I'll shut up and actually do this. So, assuming that this LED is in the right way, you're gonna hold onto it with tweezers. Oh, actually, it's upside down. Oh, that's embarrassing. Flip it over, get it in the right way. Hot air. Hold on, Mike. I'll explain that in a second. Ground. Okay. Green is ground. That's easy. So I have this oriented right. So you kind of have the component as flat on the board as you can, and then pick it up with your tweezers, but don't take it off of the PCB. So basically, you're just trying to slide it on the PCB with your tweezers. So pick it up, and then heat up the solder with your soldering iron, and like slide the component into it, and then let go, and then that like attaches it. I have to get rid of these tweezers because they're too sharp. These are some new tweezers I got or had laying around. I gotta get my dull tweezers because otherwise I'm afraid I'm gonna scratch the board. Cathode negative, go to ground. Okay. Today I learned. Okay, so these are blunter, and I'm not worried about. Yeah. Okay, so I'm gonna push that forward a little more because I wasn't comfortable with what I got. And so that's really it. I mean, you got one side soldered. Now you don't have to worry about the other side because it's attached and it's not going to tombstone or anything. So then it's just a matter of adding solder to the other side. And that's really it. And then if you want to, you can go back and touch up the first side again if it's not pretty. Just be sure not to bridge it, but you don't want to add so much solder that you're going to touch the original the other pad. So I think that's good. Maybe a little too much solder on this side, but that's fine. Okay. All right, let's do the resistor. I gotta start making more progress because this is gonna take all night. Okay, Michael. Hello, Adam. How you doing? To answer your question, Michael, sorry if you're still around. I hope you're still around. Yes and no. I find that if you're just beginning to work with SMG stuff and you're working with populating a brand new board, I would probably recommend just manually soldering it because especially with like flat flex connectors, because those tend to melt if you use hot air too long on them. So you could definitely, for most of the, unless you're talking about something like a 3DS or like a Switch flat flex connector, those are impossible anyway, so you're probably gonna mess it up. But in most cases, unless you're trying to desolder something, then it's way easier with the hot air. But just plain soldering like this, I would just recommend using your soldering iron. It's fine. Like, I'm not gonna switch out from my normal chisel tip all night. So, all right, I gotta find the resistor R1. Oh, please tell me that these are not labeled out. Okay, so here's my caps. I'll come back to that in a second. Thankfully, there's not very many components, so this is the resistor. For those coming in that missed the beginning spiel, this is a Super Nintendo BlueRetro adapter. Oh, I just noticed the perforated top here. Jesus. This is my personal, as in for personal use, not like it's my like line or anything. BlueRetro adapter for the Super Nintendo / NES that I've been designing because I wanted to learn KiCad or KiCad or whatever. So, okay, so the resistors and the capacitors should be easier because they're a tiny bit bigger than those LEDs. No problem, Mike. Michael. Hopefully that makes sense. You can always ask if you don't. If that doesn't make sense. So resistors don't have a polarity, so you can just shove things in. But one thing you need to know is sometimes tweezers, after a while, they get magnetized, which is weird. So like these tiny SMD components might start sticking to the tweezers, and it's not like because of stickiness, it's just magnetism, which is weird. So, all right, so pretty much the same thing. we're gonna do one side, the side of your dominant hand, and then swap to the other side, like literally flip the board around. Use hot air. Well, one thing I'd actually like to do, well, I would say it's a bucket list thing and not like something I need to spend money on right now. I am definitely interested in like learning about pick and place and like paste flux or paste solder and like a reflow oven or like something like that. I think that'd be cool. Or even just pick and place. Well, I don't know. I guess that wouldn't be. But like for these bigger things, I guess you could use hot air. But I'd be worried about blowing away your little components with a hot air. All right, making good progress. Yeah, stencils. Well, that's how you apply the paste flux. I guess you could blob up paste solder. I guess you could just kind of squirt it out on these pins here and then like go over it again when you're done. There's no real harm there. Also, something to note is I am not going to be soldering on pin headers here. I'm just going to solder this kind of direct, the ESP32 dev board kind of, I don't know, manually on there without pins. So yeah, I understand that this is hard for some people. Like I don't use a microscope or anything, or like I guess I have my camera, but I don't like actively stare at the screen when I do this. I kind of just look at it by hand. But I understand that some people can't do that, and then like even beyond that, a lot of people have they can't. Not a lot of people, but some people can't, hold their hands steady enough to do this. So I know it's I wish I could. I don't know. It's hard for me to talk about that because it's like I'm not affected by it, but I understand that it's a thing and that affects a lot of people. That I wish could do the projects that I am working on, so that I could help. That's definitely not. That's not what I'm intending to say. I hope everybody understands what I'm trying to say. I don't know what that's like, but I sympathize. All right, put the resistors back because we won't need them anymore. And caps, I guess, is last. What are these things? Oh, those are the last things I'm going to get. Okay. Hot air station and a Hecko FR301. Yep. Just to work on OpenTendo. Nice, you're going to tackle OpenTendo. Sweet. Okay, here's our caps. And there's 3 of those. Now, one thing that I learned, and this is just kind of like a rule of thumb, is that anytime that you have ICs, integrated circuits, like there's these 3 voltage steppers or level steppers or whatever, level shifters, I guess, whatever, is anytime you have an IC, any kind of IC, is to use something they call a voltage filter capacitor, because sometimes there could be like, I don't know, pulses in your voltage line, right? Because all these are connected to the same voltage source, I guess. So like if one device, one IC is affecting the voltage line, that could also affect the chips next to it or near it. So in a way, it kind of prevents that fluctuation of the voltage from getting to the other chips. And this is like, I'm like bastardizing that because I don't know. I don't know enough to explain that well. But I just learned this is kind of a rule of thumb thing to have. If somebody's smarter in the chat that knows how to explain that better, then feel free. But power filter cap, something like that. I don't know. Okay, so now I'm doing the caps. So there's 3, 1 here, 1 there, and 1 here. My end goal is to, at least for this kind of project, is to make shields for all the consoles. Hey, Taylor, Geometry Wars, how you doing? My end goal is to make shields for all the consoles. Like I started a Genesis one. That was the first thing that I ever did in KiCad. However, I don't know. I kind of got caught up in that. Oh, did I even tell you the reason why I did pick the SNES? I bought the Nintendo Switch Online Super Nintendo controllers, and I wanted to use them with my actual Super Nintendo. I have a Super Nintendo Junior, so these are Bluetooth, and that's the reason I picked Super Nintendo. I also have the NES ones too, and I have the Genesis ones. How funny would it be to try to see if the Genesis controller would work with the Super Nintendo? I think that'd be funny. I don't know the exact. Oh, I do know the exact part number. Or kind of family. So it's a 74 AHCT 125 is like the family, and then this is the specific one, is the SN74 AHCT 125DR. Like, I don't know. This is a Texas Instruments one. But this has 4 inverters on each IC. So just without getting too deep in the schematics, the outside 2 ICs here are to convert the 5 volts coming from the controllers to the ESP32 dev board, to the 3 volt logic, and then from the 3 volt logic from the ESP32 back to the controller ports is this middle one, so that shifts it back up to 5 volts. Hate the NES. Yeah, it is ridiculous. Let me show you this ridiculousness. So Nintendo, in their infinite wisdom, made these freaking NES controllers Joy-Con chargeable only. There's no other way to charge these things other than to switch it onto a connect it to a switch, or on a switch charging dock. Like, are you kidding me? Like, Super Nintendo ones have the USB-C, the N64 one, the Genesis one, all have USB-C. NES, they're just like, go screw yourself. Okay, like, that's fine. Sorry. Sorry for swearing. Hopefully that answers your question, Ben. All right, just grab another. Alrighty. I have to take my sweatshirt off because I'm sweating. Yeah, I don't know what's inside of it. I don't know how hard it is to take this apart. Take this part off, but that, or just like, I don't know how hard it is to like build a thing that, like, it's just a small. Yeah, I don't know, like buy one of those cheap Joy-Con docks and rip those apart and like just take it out and 3D print something that slides in and slides off to charge it. But like, come on, man. It sounds like a Twitter rant. Yeah, it is a Twitter rant. This is bullshit. I'm sorry. It is terrible. Sorry. Okay. Sorry, not sorry. There won't be any Hail Corporate going on in this chat. Yeah, probably. And then knowing the quality of those, like, $5 Switch dock could probably fall apart when you take it apart. No offense to anybody who makes Switch docks, but yeah. All right, I think we got all the surface mount components. Like I said, I'm skipping the JST connectors right now because I will be manually soldering the wires onto them for now until I get the crimper and all the other stuff that I need to actually make the little dongles. But let's tackle the buffers / level shifters. They're called non-inverting buffers, but they're used as translators between 5 volts and 3 volts, both ways. Hopefully that makes sense. All right. Put our caps back so we don't lose them. It's always fun to see what kind of packaging you're gonna get. I know you sign, well, like when you pay on DigiKey, it tells you what the packaging is gonna be, but sometimes I just YOLO it and see what I get. Sometimes it's fun to see what I kind of, I mean, this stuff is all packaging that's supposed to be used by pick and place machines, like this tape, and there's tubes too and stuff, and I hope I didn't just bend that pin. Oh, I did. You say I bent that pin in here because I was just being a brute trying to get that out. All right, I think I fixed it. Good enough. All right, so now basically the same logic. Well, now I have to figure out which direction they go. So the dot here, I think that means pin. There's a dot on the corner. I think that means that's pin 1, which means I think it goes this way. Like that. Pretty sure. Okay, so let's. These are kind of small. These are SOT or SOIT, whatever, 14. SOT. I call it SOT, but it's probably not that. There's 14 pins and there's this small footprint. So we're gonna kind of do the same thing with those chips, ICs, and we're just gonna kind of tack down one of the ends. So I'm just gonna choose this end, and then like one of the corners, just put some solder on the pin on the piece. So, and then you can actually like pick it up with the tweezers, make sure it's oriented the right way. And again, like I said, keep it flat on the PCB, right? We don't want it lifted. And then we kind of just heat it up and slide. Try to keep it straight. You know, it's easier said than done, but. And then you can keep heating it up and lining it up, you know. If you had coffee like I did, it might be harder, but. Yeah, it's a little wonky. All right, I think that's pretty good. Then you rotate it again, and you just do the opposite corner, opposite side, and tack that down too. Everything looks kind of lined up, so that's fine. Get better as I'm going along here. All right. Just shooting. Yeah, right. So now we can try to do quote unquote drag soldering with my chisel tip. So add some liquid flux and like put a bunch of, and just, I'm just gonna YOLO it. I want to see what it does. So I'm gonna like, well, that didn't work well. Probably using too much solder. Yeah, that was terrible. Don't ever do that. I'm just messing around at this point, but I just wanted to see if it worked. Now you see I got a bunch of bridges, Jeff bridges. See these pins here and there. So I need my solder wick. Yeah, it's hard. You know, it would probably be easier if I had the J tip on here. This guy. The bent one. This is probably what I should be using, but I really want to get that Aijun soldering iron, which is the knockoff JBC one or whatever. Yeah, I'll try that, but I'm gonna yeah, I had some razor. It's just this liquid flux is terrible. It evaporates very quickly with heat, so I have better flux. Wait a minute. So if you really want to do it correctly, well, not correctly, but if you want to have fun and drag solder, you buy this VS213 amp tuck. Hey, Ryan, how you doing? Yeah, Verdor. That thing looks sick. I really want, but I spent all my money on Bai, and now with the Project Stellar, rip my money. So this is already too much solder, so I know I gotta take some off. So let's just do that. So you take your solder braid and you just kind of do it. I mean, I'm not really afraid of burning these ICs at all. And look, I mean, it looks fine. Like it's done, right? Like just YOLO it on and just make sure there's at least some solder on each pin, and then you move on with your day. You don't think too hard. I mean, just if they look dull, like if a pin looks dull, just kind of add a little bit more. But otherwise, you know, we're happy. The bigger the glob. Yes, I know some people don't like, what's his face? Or a lot of people don't like Ben Heck, but his method of soldering. So if you want to have fun and do this, you can use this paste flux, which looks fun. It's kind of goopy. You know, use that. I mean, use a lot of it. I use too much probably, but what are my thoughts on that? There is a lot there, and I'm gonna go over it. If anyone's interested, I'll probably talk about it a lot more for my retro mining news video on this Sunday. But there's a lot of features, and there's some features that, because I'm not a huge Xbox, so look how easy that was compared to the other side. I mean, I'm sure it's not perfect, but it's like I did nothing, and I was, you know, shooting this stuff while and it's still on there. Like it's still. Like if you're using liquid flux and it just evaporates in a second, and then you use this Antec flux, it's like that stuff never comes off. Look at it, it's still shiny. Look, you could like go have a cup of coffee, go have a donut, and come back and still solder with it. Anyways, that's just, it's good. It's good stuff. So you can do that. That's easier. But yeah, so the main reason for Project Stellar, one, it's required. Oops, sorry for the noise. It's required. Yeah, it is funny. I like his editing is pretty funny, because I'm sure he solders for a lot longer than he edits for his video, and I like how he just keeps in the quotes and not like anything else. Yeah, Project Stellar is cool. It's going to be required for the V2 Xbox HD Plus, so that's a thing. It's going to come included. It should come included. This thing is too much flux. Yeah, that's right. And have a giant, so use a lot of flux and a giant bottle of isopropyl alcohol. Oh yeah, that's right. Louis Rossman. I think Louis Rossman probably got that from Ben Heck or vice versa. Project Stellar. What do I think about it? I think it'll be interesting. There's a lot of features, right? So I guess it'll give you. It fixes some problems with 1.6 Xboxes or something like game compatibility, which I was unaware of. I've done both. I have a 1.0 Xbox and a 1.6 Xbox. The 1.0 Xbox has a Xbox HDMI, which was the first version of the Xbox HD Plus, and the OpenZenium chip. So they both have OpenZeniums. And then I did the Xbox HD Plus on the 1.6 Xbox. So the wiring is going to be easier. I guess it's a simplified wiring experience somehow. I think it might use the LPC port somehow to reduce the amount of wires that you need, which is cool. And it connects. The Project Stellar mod chip connects to the Xbox HD Plus V2 with a ribbon cable, so that's sick. Somehow it connects directly to Project Stellar, and that's why it's required for Xbox HD Plus. So the version 2. So pretty cool. This flux is kind of expensive, but it's ridiculously worth it. in my opinion. Yeah, and it's very cool how there's feature parity with the older versions of the Xbox HD Plus and HDMI mod, which is cool. Oh wow, I screwed this one up. I bridged all the pins together. That was fun. Yeah, there's some. So I was talking. I need to get my wire cutters. So Voltar retweeted it, and GameSack asked, GameSack said, like, I don't need all this extra stuff. Like, is this useful for someone who just wants to play Xbox games and doesn't care about the mod chip? And I said, well, there's going to be built-in. You get the wired Xbox One controller support, which is cool, a cool feature that normies might care about, not just like the advanced modding features, but he asked, if I have a soft mod, will I have to unsoft mod my Xbox first? And Dustin or Make Megahertz said that Xbox or the Stellar mod chip can detect a soft mod, reverse it, and then work. So how sick is that? I gotta take my sweatshirt off. I'm boiling. Oh, it's about 8,000 degrees in here. Uh, 660. This is probably too warm. Marcy and I'm sorry, I'm not gonna pronounce your real name. Yeah, it's 660 degrees Fahrenheit. Which is probably a little too warm for this, but. And talking about temperature with an iron is a little. It's not scientific because, one, I don't calibrate this. This iron has not been calibrated recently, so it's probably not this temperature that I'm telling you it is. I guess I gotta get a Stellar. Yeah, I mean only if you're if you're like me and you care more about actually doing the soldering than you do about the gaming. Yeah, I'm almost tempted, Veridor, to do like Xbox eBay roulette and just buy a used Xbox now and just see what version I get. Because at this point, I really don't care what it is. I just want to get another one for another video. Because I think people will be interested. I have the Xboxes that I did already for my videos that already have the Open Xenium in them and stuff. And people might be interested in upgrade videos, like upgrading from the existing mod to the new mod. But I don't have an untampered Xbox that I can do from scratch. ODE feature means it can run ISOs from the HDD. Yeah, so I wouldn't necessarily call it an ODE because it has nothing to do with the optical drive. So to call it an ODE is I know that's pedantic, that's being petty, but it's not an ODE. It just allows you to run executables because you've compromised the BIOS. So yeah, I don't know. There are some hard drive features, but I don't really know what that means because, well, I think you need to use some kind of a hard drive, some kind of a utility to unlock your existing hard drive. Like if you had a stock hard drive, you had to, if you wanted to replace it, you had to unlock it. Well, as soon as you get into modded Xbox territory, that doesn't matter anymore. You could just use a fresh hard drive, or obviously you won't use an IDE one, but there are SATA to IDE converters and the 80-pin IDE ribbon cables that make it go a little faster and stuff. So yeah, the ultimate Xbox is one that's just I don't know. Is it weird to have an SSD? Probably not. I mean, it's overkill, but at this point, is it really worth getting another spinning disc? Like, is this just asking for trouble in the future? Future? I mean, probably another 20 years, but what's the durability of a SSD versus a modern spinning hard drive? All right, this looks terrible. That was the first one I did with no flux. I didn't add any more solder. I just heated it up and re-wetted it, I guess you could say. Crap. Come on. All right, I think that looks fine. On the Stellar page, this is a kernel level ODE. Interesting. So maybe it does, in a way, bypass the at a kernel level. So that's kind of different than ODE kernel. Oh, that is interesting. So maybe there's advanced features. That's interesting. I don't know if that's the case with like a currently modded Xbox. Is that how it works with a normal Xbox like that? Like if you have a OpenXenia modded Xbox, is that considered an ODE? I don't know. Like, does that mean Stellar is a new kind of an ODE for the? I think factoring in modern mechanical HDDs and how often people really use their console. Yeah, I mean, that's true. You're not doing 300 hours of Halo on your Xbox anymore. Okay. Okay, have you seen NES RGB is supposed to be back in stock at the end of the month? Thank you, Bartleby. I know it's been a while since I read your comment, but that is good to know because I need to get two of those. So, if anyone doesn't know, I've been interested in, or I've been looking at Buy, which is a proxy service for Yahoo Auctions Japan, which is like Japanese eBay kind of. So I bought a ton of consoles. So I have coming a twin Famicom, a couple of Famicoms, normal Famicoms, and a PC Engine Duo R. Normal Xbox run game executables and files from hard drive. This is possible due to how Xbox was built. Okay, so is that technically considered an ODE? I'm not. It doesn't really matter if it's an ODE. You know, it is what it is. I just don't know. Feature just run ISO. I guess it was just like an execute from the DVD drive. Huh. Yeah, I should ask Dustin. Yeah, I should. It's rough. I haven't shipped anything yet, and it's like I've spent probably more than I should say. But anyways, I want to get the NES RGB for that. Okay, so now I'm basically gonna like hold this. So I want to solder. I'm not gonna put headers in this. I'm just gonna like solder the dev board so that it's floating, right? So like I want to pinch it kind of. And then get some solder. I'll show you what I mean in a second. And then like, I don't know, do one of these. Ugh, that didn't work. Yeah, I don't know. Veridor, that's an interesting question. However, well, actually, that Jeff Chen thing, the expansion port to controller adapter thing, is like pretty expensive. The pins. This is not working. I wonder if it has to do with the type of solder that I use. So I'm gonna do that, or the type of I don't know. the board that I made, solder it all the way down. Yeah, I could do that, but I'm probably just, I could do that, Trevor, but I'm gonna do this. I'm gonna solder one pin here like that. Oh wow, look, it's like not at all soldering. Okay, there it is. This is how you ghetto solder one of these. Is that offensive? Ghetto solder? Probably. Okay, I think that's fine enough. So now I'm gonna do the other side. Stellar will support ISOs and CISOs. Are you gonna RGB the Famicoms? Veridor, the reason I got the Famicoms, well, I actually also got the. Not only did I get a twin Famicom, I also bought the disk system and the RAM expander, so I get to work with that too. That's fun. But I also got the CPUs and PPUs from Famicoms are the same as the NES console. So, oh, I didn't even think of that, Veridor. Oh well, this is just a prototype. Doesn't really bother me if it messes up. Doesn't have to look pretty. I just wanted to get it to work. The Famicom NES, or the CPU and PPU, I'm gonna use them for my Tiny Tendo build. So they're kind of Tiny Tendo sacrificial, because I got them for $10 each. So how could you not? How could you not buy a $10 Famicom? Yeah, Bartleby. It went very quickly from, oh, I want a PC Engine, to, oh, I guess I bought a PC Engine Duo R, and a PC Engine, and a this and a that. Yeah, feel the pain. This is the time where I wish I had the knife edge tip. I have one, but I wish I had the T25 or the iJune or whatever, that I can quickly switch out the tip. Tiny Tendo is completely, I don't know. It's only worth it if you are a masochist like me. Because you could just easily spend the same amount of money, because I'm sure when I'm all in on a Tiny Tendo build, I could probably just buy, I could probably just buy an Analog Pocket, and you could play NES on Analog Pocket now. So, and have a better screen. It's not composite, because the screen that Red Herring used for the Tiny Tendo is composite input. Probably fine for that size of screen, but yeah. So I also got some discs, the Famicom Disk System discs, because I don't have any of that stuff, and how am I supposed to test the system if I don't have any discs? So I got like Super Mario 3 and stuff. Pretty cheap, relatively cheap. I mean, not super cheap, but enough. If I'm at like a convention or something, and I can like look at that stuff and see if I can buy any games or anything. A top loader Open Tendo. Yes, they're coming, Yaki Yam, soon, I think. I say soon, but that's the next. Red Herring is working on. He's gonna make a top loader and an AV Famicom one. So just heads up, it's coming. All right, did I get them all? I think I did. Gotta be careful when holding your board while you're soldering it, because solder heats up metal and the pins are metal and your fingers will get burned. Yeah, Razor, it would be neat to be able to rip, like, I don't know, I guess write my own games, so like I can have whatever game I want. All right, so that's pretty much everything. So this is what I intended, so that you could have like a gap. I know I could solder probably flush and cut the pins off, but I want to be able to possibly reuse these dev boards in the future if I want to without, I mean, I guess I could always just resolder the pin headers, is fine, but yeah, so in a nutshell, that's the setup. Now, the controller inputs, and then flash it. That's what I gotta do next. So, I've got some controller extenders. I'm just gonna do one of these just to test it, because I don't know. Actually, I do need to pull up my schematic too on my computer. Maybe I'll go over to the computer and I'll show you the schematic quickly, because I do need to look at it. Hit me. Oh, cat. Hi. All right. I'm gonna pull up KiCad. Actually, I could pull up the BlueRetro documentation instead. That's a good idea. Okay. Just gotta put OBS on that screen. All right. It's going to be for sale? No, I don't know, Yaki Yam. I think it would be. I think people would care about it, but this is the first prototype. I was considering a version 2, so instead of using the dev board, actually using just the ESP32 module, but that would require a lot more soldering, because you have to solder buttons. You'd have to solder your own LDO onto it, and those components might be smaller than the components that you saw me solder. So there's some benefit to this, because you could just plug it in USB to flash the firmware. I'm not going to put the USB port or the USB IC chip. If I was going to make one that size, you'd have to hold on a second, I gotta grab something. Oops, sorry, Anna. Hit my cat with it. This is something that, oh, what's his name? I gotta shout him out, because Nostalgic Indulgences showed me this, or he tweeted about it, or they, I don't know if they're male or female. It's a ESP32 module flasher. You see there's like pins. I'll put this over here and we'll see it on the camera after. I'll show it close up. But that you could use to, like, it's like friction fit. You kind of put the module on it, then you could flash it and then take it off and solder it on your board. But this is cool because you can flash it with the USB port anytime you want. Awesome face cam. Yeah, okay, so so here's the BlueRetro website. This is not my schematic, but this is just the project itself. So to get to the, I'll just go directly to it, and then I'll talk more. So this is super, oh, here it is. So the I guess I'll spend a couple of minutes to talk about it. Unfortunately, the way that DarthCloud set up this GitHub repository, when he first designed BlueRetro, he made a board. I guess I'll just talk about it a little bit. And I'm not DarthCloud. Like, I might say something wrong. Like, I'm not this person, so excuse me. But you can see it in the picture here. This board here in the middle is what he called it, like a universal BlueRetro platform thing. So that's what he envisioned, was people were going to create these, and then you could see this is like a DB25 connector. hold on, Yaki Yam. I'll kind of explain it better, hopefully. So this is like you would just use the. Let's say this is his board, right? So this is the universal, or it's a dark color. Let's say this is his universal board, right? So you have this, and then it has this DB25 connector on the end of it, and then you would plug in a console-specific like controller extension port thing, right? So this one is the one in this picture is the N64, and don't get confused. This Raspberry Pi case, he actually designed his universal BlueRetro thing to fit inside this Raspberry Pi case. So it is the same form factor as a Raspberry Pi, but it doesn't use a Raspberry Pi. So that was the original, or the universal BlueRetro firmware is what I'll call it, is I think probably the original way that Darth Cloud intended BlueRetro to go. And that is why the entire GitHub is set up in a confusing way, because it's in that frame of mind that I've got this universal thing that you kind of don't touch anymore. After you build it and flash it, you don't do anything with it. And then it's always the reference point of a specific console, right? So in this case, this is the Super Nintendo like Super Nintendo specific schematic. So on the right side, it's under my face, but on the right side, you can see this DB25 pinout, right? So it has all the pins, and he's thankfully, if you actually have an ESP32 dev board, it's the same. They're the same pins on the actual ESP32 module. Hopefully that makes sense. The dev board is the long skinny thing with the USB port. My shield is the thing I just soldered it onto, and the silver part is the actual ESP32 microcontroller, and it does all the Bluetooth stuff. So hopefully that makes sense. So the pins are referring to pins on the ESP32 MCU itself. Okay, so like, but it's sort of obfuscated, or it's like hidden away through this DB25 connector. Yeah, so there are people have re-engineered or recreated those, and I talked about it on Retro Modding News. There was this Chinese site that was trying to like steal the BlueRetro name. I guess that's the story, and they bought the website blue-retro.com if you are curious, but they're trying to steal the name. They're trying to take the name BlueRetro because they also have the Twitter handle BlueRetro. The Darth Cloud doesn't use that Twitter handle at all. So anyways, but they have a universal BlueRetro adapter thing. I probably shouldn't even talk about it, but just I just enjoy the project and all the different forms of it. So anyways, so that is sort of what is confusing, because this schematic alone does not tell you everything that you need to know about hooking it up to the dev board. I guess it kind of does, but not all of the consoles are this detailed as the Super Nintendo one. So the DB25 connector is basically shortcut for the ESP32 module itself. Then everything on the left and over is like specific implementation details for the Super Nintendo. So at the far left, you see the controller inputs, or the controller pinout, right? And so this is like actually it's referencing the notch on the Super Nintendo controller connector. So if I look at it this way, for player one, it's, I guess the top pin is 5 volts, and then player one clock, latch, player one D0, player one D1, player one select, and then ground. So that's the pinout that I need, and I'm gonna have to use my multimeter to buzz out. Like when I cut this, I'm gonna have to reference that diagram to solder it to my thing. But if you're curious on what I did with my thing, let me pull up KiCad. I know this is a little long-winded, but it's fine. So here's my V2. I call this V2 because V1 was trash. Here's the schematic. So what I did was I took, well, okay, so let me talk a little bit more about Darth Cloud's thing before I move on. All the pieces in the middle here are talking like these. Thankfully, the Super Nintendo is simplistic, right? That it uses all the same components here in the middle. So the reference 74AHCT125, those are those level shifters I was talking about. However, in the schematic here, it's only referencing one pin at a time. right? So it's like in this top left example right here, it's pin IO19, which is a pin reference, like an ESP32 pin IO19, goes to P1D0, which is the controller port output. So that's actually that's a reverse level shifter. So that's coming 3 volts from the ESP32 to 5 volts on the controller. And then at the very bottom here, you'll notice that on each of those level shifters, you have to give it one voltage. You give it a single voltage, right? So you give it whatever you want it to output. You don't give it both 5 volts and 3 volts. You just give it what you want it to output. Hopefully this makes sense. So in the case of this first column, so there's 3 columns, this left column here, up and down, there's four inverters, and there's a middle column here, so there's 4 more buffers, and then the last column is 4 more buffers. So it's very easy, and it's set up so that you can have 4 of those on a single chip, because one of those ICs that I soldered before, you'll notice I didn't solder 12 ICs, I just soldered 3, because each of those has 4 buffers on it, or inverters on it. So you give it the voltage that you want it to shift to. So 5 volts in the case of this first column, and then the other 2 columns are 3 volts, right? And so then whatever's coming in, it doesn't matter what voltage it is. So in the case of these other 2, it's shifting from the Super Nintendo to the ESP32. So it's going from 5 volt logic to 3 volt logic. And that's what the level shifting is doing, is it's translating the logic level. And then when it's done, like the ESP32 is doing something with that, which is your button presses. It's converting that into ESP32 voltage level logic. And then it has to come back from the ESP32 as well. So that's why you shift it back to 5 volts. So that's why there's both ways in this case. Hopefully that makes sense. Hopefully I didn't lose chat. Nobody's saying anything, but that's fine. So that's why there's 2 different voltages, because the Super Nintendo is different voltage from the ESP32, and those chips handle that for you. So, all right, so that's enough of that. So that's this is BlueRetro, Darth Cloud's schematics. Then you could also look at, if you wanted to, there's the other side of this, which is the schematic of the actual universal board, if you wanted to look into that, because it has all sorts of neat stuff on it too. But if you're going to create your own for each specific console, hopefully that might help you understand a little bit. But like I said, this is only specific to the Super Nintendo. If you go to a different console, some of them don't need any additional chips, right? So for example, the Sega Genesis, and also the N64. The N64, I made a video about DIY BlueRetro adapter with just the ESP32 dev board, and you can take apart a N64 controller extension, and you can solder it directly to the ESP32 board. It's because the N64 is 3 volt logic coming from the controller. You don't need a shifter. So hopefully that makes sense. Why in that video I didn't need additional components, but that's why I can't make a DIY Super Nintendo BlueRetro thing, because you need these the level shifters. So hopefully that makes sense. Am I still streaming? Yeah, I think I am. Okay, no one said anything. All right. I hope that makes sense. I didn't lose anybody. What was I even doing over here? I'm sorry, I'm like freaking out now. I just wanted to look up the controller thing. I have my. Oh, okay. So if you wanted to do your own, if you wanted to make up your own console one, the first thing that I recommend to do is obviously pull up the controller schematic on the BlueRetro website, but also look up. Could you repeat that again? Okay, good. That's good. Okay, sorry. I'm also sick, so it's not like I'm freaking out because I'm like socially awkward, but I'm also like drained of energy. If you wanted to mess around with this on your own, thankfully, Darth Cloud sort of gives you these part numbers. So on the Super Nintendo one, there's the 74 AHCT 125N. If you copy paste that into Google, you'll get a data sheet, and that will give you information about what that thing actually is and how it does. Mind you, those data sheets are very technical. However, it's a good stepping off point if you want to learn more and you're confused about how to go forward. So there are some like the Genesis has other components that are not just like level shifters. There's other things. I think I don't remember. It's been a while since I've done that one, but that's why you can't just like whip up one of these and be done for all the consoles, because each console might have its own weirdness. So okay, so now I have my pin out. I'm gonna go back to the bench and use this and hopefully get a controller thing set on here. If I might do my own a video that might be interesting to people to listen to, because I've heard quite a few people who were confused by how to get started with BlueRetro, and I'm not like an authority on BlueRetro at all, but I've done at least that much research. Like that is what I've done research about so far, and I know just that alone could help anybody who was interested in BlueRetro, because it's really cool. And you don't have to be afraid with like getting so this is that ESP32 programmer. See these weird pins? They're like spring loaded, so like you can mash the ESP32 module in there, and then it gives you a USB connector, so you could and the buttons too, which is cool. So you could get just the ESP32. It's very tiny pins, like castellated edges. So Ben, I wanted to, so this version of the Shield uses the dev board, but I figured out the additional components that I would need, like minimum viable components that I would need from the dev board to make an even smaller Shield that wasn't actually a Shield. It was just, a complete product. So I wouldn't need the dev board at all. I would just need the ESP32 module. And really the only other components that are additional than what I already soldered on there that I need on this board down here, the Shield board, is the LVO, which is the level shifter between the 5 volts that the Super Nintendo gives you and 3 volts. So it's like a voltage regulator, like a step down. They're called linear something, I don't know, LDO. But it's essentially, it's like steps the voltage down and regulates it, because this only runs on 3 volts. And not only is it for powering this, but it's also to convert the logic. So it powers those level shifter chips, ICs, to convert the 5 volt logic from the Super Nintendo to the 3 volt logic that you need on the ESP32. So it does both of those things. And then you would need these buttons, because these buttons do things in the BlueRetro firmware. So there really aren't that many more components really to get this to be even smaller, and it would be all in one piece. And you just need to solder this ESP32, LDO. It's a little bit of a complicated circuit to get the buttons to work, and that's pretty much it. So that would be like a version 2, but that'd be a little more difficult, I would say. So like this is like intermediate level soldering, and the other one is like I won't call it expert, but it's like intermediate plus. Yes, so the dev board gives you the USB port so that you can plug it into your computer and flash it, whereas the my board would not. So I'd have to flash the firmware first. So then you might ask yourself, well, how do you flash firmware afterwards then? How would you update the firmware? Well, I think BlueRetro, I would still have to look into that, but I think BlueRetro allows you to flash the firmware after it's already been flashed once using Bluetooth. It has this web interface that you can access with a Bluetooth 5 device. So I'm just prepping this is the controller connector I'm going to use. So I'm just cutting it off, and I need to expose those wires. So the only Bluetooth 5 device that I had was my phone. So and not only that, but like I have an iPhone, and that like there's security measures that won't like block you from trying to connect to the ESP32 module. So I had to use a special Bluetooth. I can't remember what it's called. Bluefi something is a special Bluetooth browser for the iPhone that allows you to connect to the ESP32, which is kind of cool. That allows you to access the web interface, or like the, I guess it's a Bluetooth interface, and then you can update the firmware that way, wirelessly. So that's kind of cool. I gotta get bigger wire strippers to strip that. So I don't know what this outer gauge is, but USB to UART chip on board. Yes, right. Yeah, so it's Bluetooth firmware updates. Yeah, you're right. Yep. However, I was talking with Humble Bazooka, and he was telling me something that Darth Cloud told him not to rely on that. So I don't know what that means exactly. So a lot of those fancier BlueRetro adapters actually will have. Oh God, did I cut that? That was kind of interesting. Look at that. I might have cut too deep. Well, I stripped one of them, so this is a yellow wire. Not only did I strip the outer sheath, but I also stripped one of the inner wires too, so my bad. Oh, let me just do it again, because that's kind of confusing. I don't know why he told him not to rely on that, so I don't know. But a lot of the like the custom ones you see, like probably the one from Laser Bear, the GameCube one from Laser Bear, Will's Console Mods one, and the Humble Bazooka ones, they will have like 4 or 5 pins or something, just like vias on the board where they can clip on a programmer thing and just program it externally without needing a USB. So don't know. I don't know. Like, I'm not that skilled to know what the best option is, but for my purposes, like, it's good enough, I guess. Oh God. Okay, did I do it? Okay, I did it. I got my 5 wires. So you might be saying to yourself, well, dummy, there are 7 holes in this JST connector. Why do you have 5 wires? Because some of them are references diagram. I don't know actually. What? Huh. I'm not exactly sure. I don't know what that means actually, huh? I guess I'll beep it out. You could break out the TX. Yeah, right. So they just put 4 or 5, whatever it is, vias, and then they make a jig to just clip it on and program them. I gotta get my multimeter. I unplugged my headphones again. I gotta get wireless headphones. This sucks. It's not working. Anybody have any recommendations for cheap wireless headphones that don't suck? Okay, so I'm gonna strip the ends of all these wires. This is all these. Oh, I did need to. That's the reason I opened my schematic, because I needed to tell what the schematic here was. Huh. Well, I'll do that in a second. I'm just gonna strip the ends of these. I probably should have flashed the firmware already. That way I could just plug it in and try it. Oh well. Yeah, probably true. I probably should just buy AirPods. Oh well. All right, so I have my, and if I was smart, I would tin them now before I ruin. Yeah, I'm gonna do that. I'm just tinning them because I would have to do this anyways later. Solder your multimeter. All right. Now what I want to do is for each of these pins in the front. Oh, I need to look at my schematic now. I'm not going to switch back over, but I'm just going to look. Okay, if you hold the board like this, this is 5 volts and down from the schematic, the wire schematic. So I need to find which of these wires connects to this, which is 5 volts. So I think I should be able to stick my probe in. Well, I gotta turn it on to beepy boy mode. Hello? Okay. And then one of these, I'm gonna guess the black one. The black color wire might be ground. Let's check. No. Oh, why would they do that? Okay, obviously. Or no, wait, I said 5 volts. Obviously, green is 5 volts, right? That's the color of these 5 colors that you would choose for 5 volts, right? No, red is not. So that is why you need to beep these out always, because, or use the multimeter, because they lie and they don't. No, they don't lie, but they don't always use the right colors. So green is 5 volts. So I'm gonna solder that on. And which way is the Super Nintendo? So the Super Nintendo goes in this way. So I'm gonna have it. I'm gonna try to keep it like this. And like. I'm gonna splay the wires out, sort of like that. I don't know, not even a word, but okay. So 5 volts is the top pin, top. Excuse me, thing. So just stick it through and solder. And so that will be 5 volts coming from the oh, green is ground. Yeah, yes, I know on certain like I've cut apart those thick power cables, like for plugging in a computer or something. Sometimes those have green for ground, so because what, black would be hot and white would be neutral. That's like the power like wall power. All right, so now I gotta find what's next. I don't think latch is actually. Okay, so I don't. All right, I'm just gonna see if I can find a pin. I don't think latch exists in here, right? Or I'm gonna guess. I'm gonna try to find ground. So ground is the bottom pin. So ground is this bottom one. And I gotta use the other. Hold this awkwardly as possible. HyperX has the cloud alphas. 300 hours of watch time on a single charge. My God. Don't need them that long. Let's test red. Is red ground? Nope. Is black ground? Hey! Is it white? No, it's black. Look at that. Black is actually ground. Neat. So why is green 5 volts? That's whack. Okay. So Get the other colors out of the way. And ground is the very bottom pin, so like down here. And then I gotta solder that up precariously. Hey Kane, how you doing? 5 volts. All right. Yeah, that's coming along all right. And this is not the intended end goal. My end goal, like I said earlier, well, if you weren't here, I wanted to make JST PH connectors so that I could just crimp them onto the one end of this connector, the Super Nintendo, and then they would clip in to the, you know, I could take them off and put them back whenever I wanted. All right, now I gotta find those other 3 pins. I guess I should work backwards, huh? I guess I should just find what white is. If I hold on to white. Oh, that's stupid. So I'll just work down. So the top was 5 volts. I think the second one is called latch. This one here. Is this one of these wires? Huh? Latch is yellow. So why do I only have 5 things then? Are some of those not used, I wonder? Oh no. Never mind, it's not latch. This is player 1 clock. P1 clock is white. Or was it yellow? Jesus. Okay. So I think that's player 1 clock. So that's the yellow one goes next to the green one. The 2 below ground are unoccupied. Okay, I see. So I guess they just don't get connected. I wonder why they're labeled on the schematic then. Come on. Okay. Okay, so that means the next 2 are not sure which order they go in. Okay, so red and white next, so I gotta look for. So that was player 1 clock, was that one I just did, so now I gotta do what? Latch is the next one? Okay, latch was white. Yep. So white is next. Trying to get in the hole, it's hard. Not a euphemism. All right, so again, I guess I'll buzz it out. See what the next one is. So that would be this one. So that means that these two here are unoccupied. So this is the next one. That's weird. Is that why there's a? Is that why the 4 up here, or have a little thing, and then ground down here? That's interesting. So that means, what is this? Ouch. 1D0? Player 1D0. That's red. No. Oh, yep. Yep. So that's next. Well, you know. This is definitely not a very sturdy way to have this, but works in my case. I'm trying to test it. So does that mean I should see nothing connected to the other connector? God, this looks terrible. I gotta fix that one. It's fine. I better not mess with it. So it's not the prettiest job, but I'm in a rush, and I just want to get on to doing the firmware. And like I said, this is not the intended way that this is supposed to go, but I knew that I was going to have to do this initial testing to make sure this controller part works. So that's the adapter, and like I said, the goal was to make, you could probably make these shorter if you wanted to, and then you need two of them, one for the player 1, and then you could wire up the player 2, right? And then you could have both controllers to BlueRetro. So I'm gonna hop over to the computer and I'm gonna see if I can speed run flashing the firmware, and then I'm gonna see if I can get it to work on my console. So let's go to the computer. I actually need a USB cable. I'm just gonna get everything. Actually, I'm curious. I don't think it's going to do anything. What happens if I connect it? So this is unflashed, but I'll have to plug it in to program it. Will any magic smoke come out? Hey, and I soldered the blue LED correctly. That's a win. Okay, so now I got to figure out how to flash the firmware. I know how to do it. I just forgot. Okay, so let's go to the BlueRetro website. Guess we can go through, we'll speed run the tutorial, the GitHub. So we gotta go back to the very beginning. Hopefully I don't dox myself. Yeah, right, Veridor. Hopefully I don't dox myself. Just cover your eyes. Cover your eyes if you see any of my personal information. Okay, so I'm back in the beginning of the BlueRetro website, and we have to go to module flashing, and then you have to find this very obscure link that says flashing firmware on Windows 10. So you gotta go there. So I have this flash download tool somewhere. Let me find it in my downloads somewhere. Smoke would have been fun, yeah. Excuse me. I keep burping. That's why I keep saying excuse me. Gotta look for flash download. My computer does not like me doing anything, so I'll just download it. So you gotta go to this Espressive website. Oh, is it gonna have me sign in? I hope not. So I downloaded Flash download tool. Oh, it's a new version. Maybe that's why. So if you're using Windows 11, if you want to know hack, you don't need WinZip or 7-zip anymore. You can just click when you open a zip file. You can actually just extract it all without needing 7-zip. So that's kind of cool that Windows 11 has a nice built-in tool. So, all right, so we're here. We don't need that. We don't need. Okay. We do, however, need the firmware from the GitHub. Oh, my multimeter's still on. I need to go to. Okay, I guess I have to open Flash download tools. I guess it's just this one. Virus.exe. Just kidding, it's not a virus. Oh, Microsoft protected my account. And then we want to select ESP32 because that's what we have, and develop is fine. Okay, now I have to find the firmware. So I got to go. So here's where you go back to the beginning, back to the BlueRetro. Is it? Can we go through the releases? Oh, that's just the source code and the releases. Oh, is this where I can download firmwares? That didn't help me at all. Download now. Okay, well, no. So to download all the firmware for everything and the schematics and the source code, everything for BlueRetro, that's how you have to do the firmware, I think. I'm not trying to be a jerk. So go back to the beginning, the very beginning of the GitHub for BlueRetro. Click code and then click download zip. So that downloads the zip file, the whole repository. Then extract it, right? So we extract that all again. You can always delete it afterwards, but you need everything inside there. Okay, so now I've got all the files, and then I go into somewhere. I gotta look and see where I gotta go. I guess it'll probably be in the binaries folder. Main, or maybe it's in components. Nope. GitHub, static, GitHub, nope. Configs, nope. Oh, hardware 1. This is the worst. Where's the firmwares? Did I do the wrong thing? Hey Ivan, how you doing? Hi Stadium Arts. I don't remember where the is it here? Bluetooth? Oh, no, this is not it. Adapter. Darn. Oh. Hey, cut it out. Stop bothering me. Okay. Does anyone know where the BlueRetro firmware files are? Is it in the repository? I thought it was. Let's see. Maybe it's in a separate. Oh. What? Download the latest binaries. No, we don't need to do anything with the binaries. Oh. Well, this is the worst. Sorry, I should have prepared. But it should go quickly after we figure out where the firmware is. Maybe it'll tell us in the change log here. Looking for BlueRetro firmware files. Firmware files. They've got to be in that repo. Oh, come on. Is this folder just I opened a folder earlier, and it's just frozen on my desktop. My computer just hates my life right now. Okay. Back in my downloads folder. It's gotta be in here. Where though? Main? Tools? Maybe not. Am I gonna have to reference my own video? All right, forget it. I'm gonna have to go to my own BlueRetro video. Because I forgot. It's a me. So look, there's a in the releases there are firmware files. How come? So let's go back to BlueRetro. I was just in the releases. Here, release, right? 220818. Where's the third? It just has the source, right? Where's the firmware? Maybe it's only on here. It says download or now on the itch.io page. They were all moved off GitHub. Okay, well, my bad. Sorry, guys. I guess I gotta. Do I have to? Oh, sorry, Darth Cloud. I think I owe you one. Oh my gosh, that itch.io page is the worst. I'm sorry. All right, but we got the firmwares. Woo. Okay, so this is what we need now. We got all the firmware. Chris Pratt is the voice of. I watched that. Somebody made before the trailer of the Mario movie came out. Somebody made that like, they were like animated their own trailer, and it was just like Chris Pratt, like impersonator voice. It's a me, a Mario. Okay, thanks, Razor. We figured it out. Okay, so back to. Where's my this thing? ESP firmware. Okay, so now at this point, I think I've got to press boot or enable. What gets me into the I think it's enable. Do I just, I guess it's probably boot. It's like I have to hold down the boot button. Chris Pratt. I don't know if that worked. So I held down boot. So that's supposed to put it in like the dev mode. So if I have a UART now here, or the COM, okay, COM 3, I'm guessing that's right. If it doesn't work, it'll blow up. Okay, so I've got this. And I'm gonna put this here. Just watching One Piece, don't judge me. Okay, so now I need, where did the pictures go? Pictures are gone. Oh, they are. Okay, so I need the bootloader file. I think I have to unzip. I gotta unzip the firmware. Okay, so done. Now I can close all these 1,000 windows I've got. So now I've got to select the bootloader, which is in that that version repository that I got. So I gotta select. Oh wait, no. So on the top level. Wait. Yeah, here we go. On the top level. So as soon as you go into that version, there's other folders inside of that. So not this top level, but you gotta go to the bootloader folder first. So now we have this bootloader binary. Select that, and then we want to select. I believe this is the address, memory, the address of the memory we're gonna flash that binary to. So I didn't explain that ever in my video, but I think that's what this is. This is where in the memory we're flashing this binary to. All right, now I need the partition table binary, which is back in the other folder, and that's at memory location OX8000. And now we need to select, in the picture on the GitHub, it says, oh, sorry, I think you can't see the numbers I'm typing in, but I'm following this picture on the left here for the numbers. On the third thing, so we did the bootloader and we did the partition table. We didn't do the universal, or now we're doing the third one, which is the actual. You can either do the universal firmware, but I'm going to do the Super Nintendo specific firmware, which is back in the top level folder, version folder, and then under SNES external. Yes? Yeah. SNES external. And that is at location OX 10,000. Okay, so now that everything's working, I think all the other settings have to match, so do not change bin, DIO, 40 megahertz, okay? Now if I hit start, I think it should flash it. Sync? Oh, so this is where you have to press one of the buttons. Enable? Boot? Maybe it's enable? Oh, actually the other thing should be yelling at me. See this? I think it's enable. Not doing anything. Kill? The other one maybe? Boot? Oh, there we go. So I held down the boot button for like 3 seconds. And now this says download and finish, so it changed. So this other window, when you have the flash download tools button, the other window, this like command prompt will open. And that is what tells you to like, so it's not straightforward. So you have to wait for this other window to have the dots, and then you have to hold down the boot button after you plugged it in already. So I think that's it. So that's flashed. Okay, firmware's flashed. So now, I don't have a great way to, let me turn on my RetroTink. So I've got that going. Maybe? Hello? Oh, I was using the USB port for the flasher. Okay, RetroTink, turn on. Okay, game, turn on. I believe you also have to tick the boxes for each of them. Oh, yeah, I think I yeeted that window closed. I was so pissed off at it. Well, we'll see. If it doesn't work, then it doesn't work. Okay, I don't have a great visual, but, or maybe I kind of do. This is not, don't trust this. This is, oh, I'm falling. So I've got, oh, this is precarious. I've got my Super Nintendo Junior, RGB modded. I have HD Retrovision cables, and I'm trying out the Triad with the red adapter to reverse the polarity. So that's nice. So I'm going to plug my thing in, first slot. And, ooh, those cable extensions fit in there pretty good. And, you know, the controller, I need to turn off my soldering iron so I don't burn out my house. Okay, so when I turn this on, the thing should pulse. Okay, wait a minute. Oh, I know what I'm doing wrong. I have to select YPBPR. Hello? Menu. Oh, hello. This remote that comes with the RetroTink 5X. Oh, I know what I did wrong. I was using my PS5 and my HDMI switch sucks. There we go. Did it. Doesn't auto switch anymore. Okay, so YPBPR is fine. So I don't know why the maybe I did need to select the because normally when it's the BlueRetro adapter is looking for controllers, this, I know it's super hard to see and it's blown out, but this should be pulsing. The extra LED that I soldered onto the shield is like the status, the BlueRetro status light. The red one is like always on when the thing is on, but this blue light should be like, it pulses when it's looking for a signal, and then it's solid when it detects a controller. So that tells me that the firmware didn't work. So I gotta plug in Plug it in. We're so close, guys. Sorry. I think whoever said that it needs to be checked is probably correct. All right, back to Flash download tools. I hope so I have to select all that crap again. Cool. Actually, I think Flash download tools saves stuff. Oh, forgot to switch it to my desk. No. Jeez, this. Where'd it go? Hello? Oh, now what? This just doesn't want to open for me a second time? Well. Is it open somewhere already? This is whack. What would it even be called? Well, Flash download tools didn't want to work for me again. Maybe can I like extract it? What? It didn't ask me to do this before. Oh, was I just opening the zip file again? I'm a dumb. Tired, guys, sorry. All right, ESP32, develop. Okay, great, now I have to do this again. It's fine. We're almost there. All right, speedrun, bootloader. Boom. OX 1000. Check the box. Boom. Open. Partition table. Boom. OX 8000. Check the box. Boom. Open. Version. Super Nintendo. We did it. OX 10000. Check the box. All right. Click start. Look at the thing. No log output. Oh, select the COM port. Start. Hold down the boot button. Flashing. We're doing it. Taking a long time to. Oh, okay. This is a good sign. It's taking a lot longer. Before it took like 2 seconds, so I think we're actually flashing the firmware this time, which is good. We're almost there. Finish. Woo! Is stub incentive flashing finish. Woo! We did it. All right, I might as well leave this open because I don't want to do that again. All right, back to the game. Plug in my. Okay, so what happens now if I turn my SNES on? Does it pulse? Oh, it's off. Why is it off now? Now that light is off. Maybe that's fine. Well. Oh, it's pulsing. It's pulsing. It's working. Hold on, I'll just plug in my RetroTink in. All right, RetroTink is turning on. Got the Super Nintendo's on, and I don't know if you could see in the light. Maybe if I turn this off. Can you see this pulsing now? Yes, the blue pulsing. So that's why I added an LED to my shield. Is because it. Sorry, I'm looking over here because the chat's over here. The pulsing indicates like the status of BlueRetro, because now it's searching for a controller. So now if I take my controller, turn my light back on. Cat, get out of here. And if I press start, or maybe the sync button, Turn this thing on. Hello? How do I turn this on? Turn on. Start the select button. Oh, okay. So I'm searching. The BlueRetro is pulsing. Is it gonna work? Oh! 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 Pog! PogChamp! It worked. Alright, now let's I don't know why the RetroTink is not, it's blue. Yeah, YPVPR, right? It's my, why is it blue still? I'm afraid that if I okay, so I turn the Super Nintendo off and back on again. It's pulsing. Let's see if it recognizes the same controller. So the Super Nintendo controller still has its light on, but the BlueRetro adapter is flashing still. I think there's something wrong with something. My SD to SNES. I didn't blow in it because I was blowing on the cartridge, but is there something wrong with my flash card? My flash card? Is there something wrong with the I think everything should be working. Motor cables are connected. Okay. Component switch on right input. I'm not using the component switch right now. I'm just using the wire straight into the thing. Hey Belmont, how's it going? Hopefully, why is this not working? Infuriating. Why? Why you don't work? I feel like it's my Super Nintendo. Should I bust out my other Super Nintendo? Fine. You did this to me, Mike Chi, or whoever is responsible for the problem I'm having right now. A busted ass childhood console. It could be. Is it the? Maybe it's the triad. Am I screwing my consoles up? Hey, I'll be able to RGB bypass this whenever Voltar releases his thing. So that's cool. All right. SD to SNES goes in there. My BlueRetro goes in there. Oh, it was on already. Whoops. That goes away. Something has to be wrong with. Should I try my my real Super Nintendo? Oh, I'm an idiot. Wait, I'm not an idiot. No dupes in Switcher 9000. I don't understand. Maybe it is the. I'm trying to think of where the Super Nintendo power adapter is. Maybe it's the triad. Well, I didn't expect the BlueRetro adapter to work and not my Super Nintendo. Does the original Super Nintendo AC adapter work with the Junior, SNES Junior? think it should. All right, so I have my original power supply. Check it now. Really? The Triad did it. What? That's whack. And now it's just black screen. What is this? I'm losing it. Maybe this is just my... okay, now I'm going to switch back to my Super Nintendo Junior because my old Super Nintendo has probably needs some TLC. I don't know. Okay, main screen turn on. Why? Bro. You think it's because of the BlueRetro adapter? My SD to SNES is flashing. I don't know what that means. Is this a terrible... This is a terrible flash card? Or SD card? Okay, it's not flashing anymore. Why is it still blue? Well, this is not how I expected this to end. Try regular cart. They're all in my closet though. All right. Star Fox. Yeah, the BlueRetro adapter is unplugged. It should boot without a controller, right? It doesn't need a controller in it. Star Fox? What? Then what is wrong with my SD to SNES then? Maybe something's wrong with the firmware. Maybe I should try updating the firmware. Okay, well that's weird. All right, plugging the BlueRetro back in. I've had this. It's possible that it's the. What is this SanDisk? Crappy. Maybe this is an old. I don't know. It shouldn't do that. I've used this recently. Okay. So let's turn on my cat. So the BlueRetro adapter is blinking. The Super Nintendo controller is off again, which is fine. So now if I hold down the sync button, it's doing the switch looking thing. Oh, the light's off. Oh, it was like instant. Look at that. Cool. Connected. Is there no audio? Hold on a minute. No, cat. Okay, start button worked. Start. I don't know if there's audio. Hold on, I have to let me turn off the music. I don't know what's going on with the line in. I bought a new mixer, stereo mixer, so like I have my record player, my HDMI splitter, audio splitter. Okay, audio is not important. All right, it might be my stereo mixer. Okay, so oh, look at this, left, right, up, down. All right, let's play. Start training. Oh, training. Well, actually, you know what? Oh, pause. Pause. Wait, no. Damn it. Okay. Put OBS over here. Put my game over here. Oh, my cats can't get out because the box is in the way. Sorry. Sorry, Anna. Okay, here we go. Training. Let's just start the game. Here we go. It's been a long time since I played this. So this is the Nintendo Switch Online and Super Nintendo controller with BlueRetro. I guess audio is borked. I don't know. Maybe I need to do this. Wait a minute. Oh, wait a minute. I'm a genius.
Good luck.
Am I a genius? Should there be music? You guys hear music? Oh wait, you guys might be hearing. I don't know what you guys are hearing. Sorry. This is the worst without music. All right, here we go. I don't remember how to play Star Fox. Oh, bomb! I know those bombs, right? How do you shoot? Whoops. Oh, why? Fly, wee. Wow, this is fun. It worked. Look at that. That's cool. I did it. I did a thing. Oops, and it's inverted controls. Fly through the rings. Wee. Nice. Okay, yeah, nice, Verador. This is very thrilling. Pew, 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 pew. Very cool. I did it. So that means the schematic. Just follow your dreams. Follow the schematic, and you can do anything. Follow someone else's schematic. Don't come up with your own. Follow someone else's schematic, and you can do anything. Let's turn that music back on. Did that work? I don't know. Everything is messed up in my It's really loud? What's loud? Oh! What's loud? Are you being sarcastic? I know there's no audio. Follow someone else's stream, yeah. Hey, you know. Or I guess in this case it's implement someone else's dream. Someone else wrote their dream down. I picked that dream up and I was like, that's my dream now. I know there's probably some amazing controller sounds. Oh, silver. Oh, okay. Getting to the end, boys. Oh, God. Oh, no, the blue thing. Oh, really? Oops, I forgot to help Slippy or whatever his name is. Oh, I got him. Did it. The sound was working? Now it's not working? It's not working for me, so... I muted it, so maybe it works now. There we go. I don't, for some reason I don't get sound, but you guys get sound. That's weird. I think it's should be working now. Hopefully it's not too loud. I'll turn it down a little bit more. It's been a long time since I played Super Nintendo Star Fox. Easy peasy. Oh, God. We did it! BlueRetro for life. Oh, I should have worn my BlueRetro shirt. I'm an idiot. All right. I think that's about wraps up tonight's very long episode. No, it was about 2 hours. BlueRetro works. So that's version 1, the shield. There's some tweaks. I have to make some bugs with the layout. I gotta just little things that I learned from both tonight and when I was working on it originally, and stuff that I've learned since then. So I'll make some tweaks, and I don't know. I wasn't considering selling them, but they're really not that difficult to build. And I realize some people might, you know, the nice thing about the ESP32, the nice thing about the did I mute somehow my other thing? I don't know what's going on my computer. My BlueRetro. The nice thing about this version of BlueRetro, right? Like using the ESP. Wow, the ESP32 is hot a little bit. Not hot, but like warm. Interesting. The nice thing about this is you can easily flash the firmware with USB. It doesn't look the greatest, although I could probably whip up a 3D printed case to put on it. But I mean, I built it in what, 2 hours? I know I knew what I was doing already, but in 2-ish hours, I had a working BlueRetro, and not too expensive, you know. I mean, the dead board is $10. All right, yeah, I'll have to find out what's wrong with my SD to SNES. But I don't know. So if you wanted to build it yourself, you know, it would probably be, I don't know, $20, $25 or something, maybe more. But I probably could get it a little bit cheaper if I can, you know, build a bunch of the boards and have all the things. Well, maybe it'd be a little more. I don't know. Like that's a lot. It's a lot of work. I guess it's a lot of work. 2 hours for one. Unless I find a way to have like JLC PCB solder those components on for me, and then like I sell it as a kit. Like you get 2 extension cables, or maybe I can make the controller part, the JST connector parts myself. My design tone. Oh, design time. Yeah, I know that. But I don't know. I guess I'll put like a. I know some people were interested. They wanted to buy them. It doesn't look pretty. I mean, it doesn't have a case. But the other thing is too, if I had more time, I could solder up the second player. So you don't need 2 of these. You could just, you know, a lot of the, like the N64 one, the PlayStation 1 one, you need 2 adapters to get 2 controllers to work. You just need one of these. Like all of my shields, I would design them because the BlueRetro project is designed for every controller to be used off of one ESP32 module, one of these. So for like N64, it would have 4 controller ports on it, and that's actually the Retro Rossetto. I think I talked about it on my Retro Money News. That is kind of the same thing, although his uses the universal, or maybe no, it's not. I don't know, but it's something that you could build, and it's simplistic. Like I do the hard work, which is figuring out the schematic and doing the layout, and then you just got to solder yourself. So I don't know, not really sure, but thanks everyone for sticking around. Stuff I have coming soon. I'm gonna have that stuff from Bai. So I'll probably share that on Twitter. Some consoles coming, interesting stuff. So Twin Famicom, PC Engine Duo R, the Wonder Swan Color. I bought a second one, and Zwenergy just released his files for like a beta version of that. So we could do that on the channel, on the stream. So thanks everybody. I'll communicate on Twitter and YouTube maybe for when I'm going to be streaming next. So thanks for hanging out with me, and BlueRetro.